Applied maths, linear acceleration. If you have an object that is accelerating and then immediately decelerates, you can use the following method. Now I'm going to derive this first, and then I'll show you the three formula that you'll need to solve a problem like this. First off, the velocity time graph looks like that. I'm going to split the total time, which I've called capital T, into the time spent accelerating, T1, and the time spent decelerating, T2. If you're given the acceleration of A and a deceleration of D, I normally write them like that. And now what I'm going to do is take a look at V is equal to U plus AT in the acceleration section, first of all, and the deceleration section. So the acceleration section, that's the green line going up on the left, the U is 0, and the maximum velocity there we're just calling V. In the deceleration section, remember the acceleration is the negative deceleration, which is why we have a minus D instead of the A. T2 is the time taken for it to decelerate, and then the final velocity is 0 because it's at rest, and the initial velocity is the velocity at the peak of that graph, which is the V, which is the same as the formula on the left-hand side. Now, if I rearrange that formula, I get that, and because the V's are equal, I can equate both of those. Now I'm going to rearrange it as a fraction. So the acceleration divided by the deceleration is equal to T2 over T1. So the acceleration in the first section divided by the deceleration in the second section equals the time in the second section all over the time in the first section. We came across this already when we said that if the deceleration was twice the size of the acceleration, that meant that the deceleration duration or time period was half that of the acceleration section. And that's what that's saying there mathematically. The other way to write this is in ratio form. Now, that's the derivation of how we get that ratio. We would have covered that in class. And now when you're doing the question, remember that there are three formula that you need to take from. First off, we'll just put that up there now, is the ratio formula. So you want to change from a ratio to a fraction of the total time. And I would have covered that in class. The second formula is use V is equal to U plus AT in either the first section or the second section. You'll find I generally use the first section. And the last thing then is to use the area underneath the graph. So it's a triangle. And the displacement is, that should be half of the base by the perpendicular height, where the perpendicular height there is capital V, and the entire base of that triangle is big T. Remember, that should be a half, not a third. There's a misprint there.